be having a presentation now. I would just 30 seconds for our presenter to join us. We will share your screen after we introduce you. Would that be okay?
Okay, yeah.
Okay, okay, thank you. Okay, it's perfect. It's fine. Okay, I'm just gonna start over. We're gonna start recording now. Okay. Welcome back, everyone, to the industry track with Zaina Nabusi from the University of Warwick. She is a PhD candidate in structural engineering. She will be presenting to us metal 3D printing in structural engineering. Just a few words before Zaina starts, I would like to say about her. Zaina is a civil engineer who specializes in structural steelwork design. Can you mute yourself, please, Zaina? Okay, thank you. So as mentioned, Zaina is a civil engineer who specializes in structural steelwork design, metal 3D printing, and modern construction technologies. She has 3 years experience working as a structural engineer in the DAR group, where she was involved in designing international and large-scale steelwork projects. Designing such challenging, innovative, and costly superstructure made her realize that she must pursue structural engineering at more advanced academic level. Currently, Zaina is busy with her PhD at the Warwick University, as I mentioned. Her research is on the potential of metal 3D printing. She strongly believes that this is an exciting method of manufacture, can be used for full-size steel components in the future. In 2019, Zaina received a Commandment Research Award in the structural engineering organized by Midland Counties Regional Group in the UK for a research paper called The Potential for Metal 3D Printing in Structural Engineering. In addition to her full academic and professional involvement, Zaina is a STEM ambassador and for 5 years has been an active member of Midland County's Young Member Group of the Institution of Structural Engineer. Welcome, Zaina, and thank you for making time today to share your metal 3D printing in structural engineering view. You may share your screen.
Hello, everyone, and thanks for the nice introduction. I'm really excited to be here today. I think it's a big day for all of us, and it's nice to see how we're encouraging women, or how we start encouraging each other. Yes, this is... thanks again for the introduction. I'm just... Sorry. Yeah, this is me, as Malika introduced. I'm a civil engineer and currently a PhD candidate at Warwick. My Viva is next week, so it's a big week for me. And currently I'm a part-time structural engineer at Dawes in Manchester. This is me while doing the printing in different collaborators. And in 2019, we got a commendation award from the Institution of Structural Engineer on a research paper that submitted, and we're trying to push the construction, the AM in construction further. Also, I've been lucky to introduce my research outcomes in different conferences in Norway, Australia, China, and the States, and different places. So I'm really excited again to be here to share awareness and maybe to inspire a younger generation to take this technology forward and push it more. So the more we talk about it, the more we believe in it, I believe. So what's happening in the construction industry? This is what we're going to start. What was the motivation and why we need to talk about it? So we've seen a lot of updates all over in all profession and how they start using the 3D printing. We've seen it in the medicine, we've seen it in the automotive, we've seen it in gas and oil. You can see how it's start helping us all. So the question was for us as structural engineer or construction, why not us? Why not us? When I started in 2018, I started seeing the growth of concrete printing and construction. We've seen how from its early stages till 2008, it was in a steady stage, but later on from 2008 till now, it's an exponential growth. There are also a key marks projects that's already been in the industry, and we heard about companies that start printing houses in 24 hours. We've seen people living now in 3D printed houses. We start seeing it's going globe in all countries, each country. And it's all started here with these are key milestones project that we will always see them when we're talking about concrete construction. The Aerospace houses in China, and how Dubai is trying to push the AM industry in construction to have a minimum of 20%. So all buildings have to have 20 or to 30% to be 3D printed in 2030. So we've seen how it's being pushed. Taking that forward from a 38 meter square concrete house to 640 meter square house in Dubai, and you can see that here. The yellow one was being printed in a cold weather, however, the opposite, it's been in hot weather. We've seen in Italy houses that been printed from soil. So we can see how all these development coming forward, not just in houses, we've seen it also in the bridges. So these are two design bridge. The one in 2040, Paris is working toward printing a 40-meter span pedestrian bridge for the Olympics. And we already have seen the bridges in Amsterdam with 30 span is on site. This is all about concrete, but how about metal printing? And where are we in the metal 3D printing? So also, just looking at different scale, we've seen different scales here. We've seen in 3D print and metal printing in 2018 when it started that we have that replication of small columns done by Imperial, Arab connections about optimization, the micro lattice structures. We've seen a seismic damper. So we've seen small key elements that started. And of course, all of us heard about the MX3D bridge that had pushed the horizon in the AM printing and show us what we can do in a larger scale aspects. So these are the development in the AM, the early stages development. There is much more, but these are the key starting points. And we've all seen in 2021 that finally the MX3D bridge is on site. After a lot of tests, if we heard the journey apart from printing, designing, the approval and the metal testing and all this, because of our classic construction, because it's our safety, we need to make sure everything is safe. So I'm talking about here about confidence in materials and our safety. That's might tell us why it's still slow in the construction. I've shared different applications and we can categorize them in 3 main points. We can see how we are redesigning structures. The redesigning could be for structural and for non-structural elements. For structural elements, we've seen the beam columns. For non-structural elements, could be in the cladding, could be in windows frames, could be in fake connections, just as studying things. So we've already start seeing it. And the enhancement, could come from different applications that I will talk about, and we already seen it now with the dampers. And the question is how we can take it further to application on site. What was the motivation? And when I started the motivation, all seeing that iconic design in London, in St. Pancras, how earlier when that was built, the material was expensive and the labor was expensive. So that's mean when we design, we have to optimize as much as we can do. Also, we have a fantasy nice shape that please the client and the architect. So the question is how and when we could come back to this. So that was the motivation. will 3D print be the way forward to have more optimized design? So this is the vision, and I think this is the vision for all the AM industry users in all different fields, is to have an optimized structural engineering designs using this novel manufacturing technique. But everything takes steps, and we're still earlier, we were in early stages, but we still have that limitations. But the more we highlighted it, we know the direction. These were limitations, but we're still improving it, but it's still coming. So we have that limitations on the design softwares, the techniques, the materials, and the knowledge. And also, it's really important for the market to know what application or when we can use it, because you want to get some feedback from it. So when you start, you would see that limitations. If you have your printers in-house and you start printing, these are my early stages printing, and you can see the porosity, you can see how the melting is not proper, you can see how different type of failure you can recognize, and everyone will have it, you would see that. So there's a learning process for us. I will just go quickly with you to see how the printing process, what we printed in my project, what are the tips and to take it forward. So we know that we have AM categorized the AM to 7 process. So the one highlighted in gray is being used in the concrete, but the one has been highlighted in cyan is which is the powder bed, and the DAD is being used in the metal. So when anyone will start, you will ask yourself, is it powder bed or is it DAD? And for construction, in my design, in my research, I've used the DAD, not the powder bed, because I believed it has high deposition. I'm not limited with the room chamber. I could have more high material utilization, and the time needing was different. And mostly that governed me is the size, because we're talking about construction. In my research, been very lucky to collaborate with Estilo in London, with Autodesk in Birmingham, Ramlab in Rotterdam, and we used the Autodesk movable cabin there. So we've used the WAM technology, and we've done different testing. For you guys who doesn't know what's the WAM technology, this is a quick show us how the printing process happens. Robots, we can see it's like a welding process, and we can see how that bead has been printed. I shouldn't have taken the pictures, but I took safety when I've done that. So it's like a welding process that's building us a layer on layer, or filling a 2D while we're doing that. If we went deeper to see how this weld being, or that bead being built, we can see, yes, it's like a wire that's going down, melting and filling things, but how the interaction. I'm asking questions that have been asked while I'm doing the research, because we want to make sure that's giving us a good, strong material. And these are the 3 main steps that all 3D printer users need to follow, or already following, which are, we need to optimize the parameters. And for us who's new to this, we need to see how to optimize what's the speed. Coming from civil engineer background, and need to learn about welding, what height, what speed, what's the voltage, because if you see in that white picture, you can see different beads, and all have different widths, different height, and different porosity if we're not doing the right optimization. So we need to do this exercise before we start, unless we have softwares now that we could depend on it, but we need to do that exercise to optimize our bead. And then we need to do another exercise to optimize that between each layer bead, which is called step up or step over distance, because all this will affect the overall results. Then in structures, this is something that we need to keep in mind, that our thickness, and when we are doing the design range between 10 millimeter till 20, so you won't have bead width that width when we're doing the WAM technology. So we need to think about the path planning process. Are we which one to use? And Bridging between both technology, I would say, if you are familiar with these rasters, exact contour, and so on type of path planning, I would go for the rasters or the contour, and mostly the rasters because it has that welding basis, which has already a benchmark design code in the structural industry. So the rasters was followed in the application that we already done in my PhD work. So what we printed is, you can see here with the one on the top, the welding torch, we can see a plate and we can see the lines and we can see the rectangular shape and we can see the eye section. So the first shapes were fine with just one bead, but with the eye section, yes, I started with an eye section. I know that technology is for more optimized components, but we need to benchmark it. And coming from that old school, I thought the eye section is a starting point because all our design code talking about the eye section, the normal in design, in addition to circular and hollow sections. But for the eye section, I'm talking about these depth, the 10 and 20 millimeter. So one bead we can see it's not enough. So we need to think about the path to fill this 2D. And I'm highlighting this because I want to share that knowledge to push it forward. So which is the path and which was the more optimized one that was happened in the research, and we studied we printed different shapes and we studied the material for that to see what's the difference and how to do it. So path planning is the next step, and then printing strategy is another step. From structural point of view and construction, we need to see where is the failure will happen. So we need to ask the client, what's the purpose of that joint or what's the purpose of that component, so we could know where's the failure. So in my research, in collaboration with RamLab and TU Delft, I've asked them to print that beam to column connection. And because I've said a beam to column connection, so we thought about where the failure will happen. So it's going to happen in the joint. So in the joint between that column, I don't know if you see it, that column and the beam. So then this is the key points where it's highlighted in yellow. This is the transition zone. So when we've done the printing, we thought about a special process to make sure this is our strength. And the printing strategy was a two-directional because of the shape. So we started printing the columns and then the beam. So these are different steps. The more we know about it, we take it ahead in the concept starting point. So summing up, after all this learning process, from seeing that porosity in the beads and in the walls to the learning process in the project, these are the printing components that's being done. And these could see a potential application. How I'm saying that, why? So I would start with the Autodesk plate, which we printed it in Birmingham. It was a starting point, a plate. This is how you would see it. But how I will see it is for an old factory, which has a rusted and after time, it has a weakness in the plates and the flanges of the printing. The robot can go there to that factory and print extra layers to thicken the design to make sure it is safe. So this could be one of the application is the enhancement stage. Yes, we still need to research what's durability, but it could be, or how the connection between the old and the new steel will happen, but enhancement is one of the way. The other application was at Stilo, where we are thinking when we think about fabrication, we want to minimize the number of labors. So we need to automate the welding process. So we could think about that one technology could be used as printing the fin plates on site. So, or in the factory instead of shopping and cutting things. In that eye section, the rectangular hollow section and the beam, it was a replication for the current design. We see it already in our houses and everywhere, but we need to start somewhere to benchmark it. So all this been a learning process for us to push that forward. But again, coming from, that was the printing, and this is our beam. This is me in the lab, and just showing you the size of the printing. It took us 100 working hours, but it was mostly learning hours there. So Coming from back to the civil world, yes, we did the printing, we learn about it. We want to see how to make sure what's going inside and how to convince a future user that it is safe and we could take it forward. So we did XCT scan and we did a destructive test. When we started with the XCT scan, we did in collaboration with Work Manufacturing Group, we studied this. We scanned most of the element to see what's the relation between the printing process, tensile testing, characterization, and inside the component. And you would be surprised to see all this. It was mostly my printing, so I would expect to see a lot of porosity in all this. It was so we know why we have porosity, we know the location of the porosity, and we know the links now between the porosity and the tensile tests, the readings that we need when design the characterization. We've seen how the printing, we can see how the interfacial, so if you can see between each layer, these fancy colors in the left, we can see why we are having it. It was because I haven't optimized the printing, the step over between each layer, it wasn't right. And we can see the density is different. That's why we have it in between. And we can see how the porosity are in between these layers. So it was learning process. And the funny part is after exploring this, we know the parameters, we know the XCT, we've studied I'll come back to this, we've studied then the tensile test, which I'll explain later. For the beam to column joint, when we did the XCT scan, and because I've showed you how we did that transition between the beam and the column, and you can see in the right picture that the white color, the white here, the white printing or the white captures photo because it was dense printing. And this we can see it with the XCT scan, and we can also see it later with our results. So this is due to this, which I said, like the tapered printing layers before going ahead, and we can see it. So we studied the XCT, and then we had to do the tensile or the destructive test to see how strength, what's the strength, what's the F yield, what's the F ultimate, because this is any starting for designing process. We did tensile, we did impact, and we got really brilliant results. For the mild steel, we could see how we achieved the design code, the current Euro design code limitation with the porosity, but with a minimum acceptable porosity, which was less than 1%. So I'm highlighting this here, and for the high strength, we achieved the 10% elongation, we achieved the F ultimate to F yield percentage, and we've seen the cup and cone failure. So why I'm highlighting this? Because it's an early stage for AM in metal, in construction, and we already know that limitation and the porosity. So when casting started, we accepted a minimum percentage. So in my research, I'm trying to push that forward and accept minimum limitation at early stages, because building confidence is vital for structural, because it is our safety. We're living in the houses or we're stepping on the pedestrian. So after seeing that we are applying that, we're getting that, we've done a beam to column connections test. We've studied the stiffness and the rotation, yes, for a conventional beam, because later on you would see a flowery, you could see a star beam, you could see whatever design beam, but we need to start somewhere with something to bench it. So that was the starting point, and it gave us a results that is applied with the design code and where it could fit. So that was very optimistic to take that and to share that knowledge and to take it forward for future application. That we already seen the technology in the gas and oil. So why not in construction? Why not doing that in our fabrication workshop? Yes, we've seen MX3D printing that fancy joint and that columns. So the more we did that research, we could take it forward. But my advice is to always ask, where's the load path? Ask that structural engineer. Ask them what's the key elements, where the failure will happen, so we think about it. And also, the more we know about it, so once we know about these key, where the failure will happen, we will think about it, because we want to push the industry further. Don't take it as just a fancy shape. ask them. And also as a starting point, we could design things that is not a key element in the building, but it could be a plan where other element could replace it if anything happened, because we still doesn't know the future of it. So it's a mix of words, it's a mix of positivity and challenges, I would say that way. So if we think about the challenges, like any new innovative technology, we still doesn't know what's the long term. We still have imperfections. We doesn't have enough standards. We still see the porosity. But looking at the positive side, yes, this could be the way further to engineer our design to have a sustainable design. We always hear about the carbon, and we want to minimize the carbon effect for our environment and for the sustainability. So this could be a way forward for us to optimize our design, to have a more parametric design. We've seen it. We could apply it now with the AM technology. And if you ask me about porosity, I would tell you, start using it. You've seen the static word load here. You could start using it in the building. Avoid bridges for now, because you don't want to be questions about fatigue and about future crack, but you could find a way by telling them, yes, in the building, I don't need to specify this for now. So it's innovative, but we can take it forward. Again, I'll ask this question: when it's us, it's the younger generation, and also the big generation who's leading now, and take that, all the CEOs and all the directors who could make a step to take it forward. Believe in the technology, give it a chance, and let's come back to this more optimized design. And yes, let's talk about it and let's raise awareness about it. And thank you all for listening. And if you have any questions, I'm all with you. Thank you.
Thank you for your presentation, Zaina. It was very interesting. I hope the participants enjoyed it as much as I enjoyed it. We have a few questions for you.
Yeah, sure.
First of them is, what development do you need in metal AM processes to push AM construction to the next level?
What's that?
Okay, I will repeat again.
Yes,
what
please.
developments do you need in
Yes.
metal AM processes to push AM construction to the next level?
So I would say softwares, because we want to have a more useful softwares for structural engineers, because we're designing, okay, we use a lot of hand calculation to do our designs, but we depend also on softwares. So we don't know how much we could really relate the current results from the AM or the materials with the already designed software we are using. So that was the main purpose of this research, is to benchmark it with the current design code to see how much, because we see how much we can use the current design code. But coming back, how we want to push it forward is, I believe, like, been working in this for the last 4 years, I believe the more we share where are we in the AM, share what what's the new addition. We don't want just to hear that we printed this or this is what we printed. No, share how we printed it. I know at the end you need to prototype it. I know it's also want to be a business for you or for the company, but also when you give that knowledge to the engineers that this is how it's been done, this is the results, I think they will believe in it more. And then they will take it forward, because so yeah, I hope that I've answered that question. So it's because I'm bridging between both, so it's just share with the engineer, because we need to believe in it. We need to have that confidence in the outcomes from it before using it in our buildings.
Amazing. Yeah, we have time for one more other question. We have a question here, say, have you started qualifying components for use? How would you approach that in your industry?
Yeah, so I would say we could start prototyping things. So we could prototype a connection, and we could use the same method that I've done it for prototyping, like a big fancy connection in special fabricator or something. You could start printing it, then you could get that qualification by getting the XCT scan, you get the results, and then you certify it. I know this is an old way, and it's already happening with the oil and gas now, but if it's happening in the oil and gas, and construction always is slow in adapting a new technology, and this is something that's been for ages. So we could follow the same steps in giving that certification for either prototype connection or damper in earthquake, or any new applications that it's well used at some point. So we could think that's what's needed to build that confidence, if I got the question right. You're muted, Malika.
Zaina, for the insightful presentation, and as well working through your PhD research. We hope to see you a doctor soon. All the best with that. Thank you for making time for this session. You can put your mic and camera on.
Oh, are they off? Okay, sorry. Stop sharing.
Thank you so much. Okay. Thank you, everyone. We're going to jump to our next presenter, Stephanie Breakwider. I would like to bring her to the stage. Yes.
Hello, good morning, Lynn.
Welcome to our industry track stage, Stephanie. I would like if you want to share your screen first. Okay. Okay, great. Thank you. I'm just gonna start recording before I start introducing you. Okay, again with another amazing presentation that Stephanie Breakwider will give us on AM on Track, how 3D printing improves the quality of life. Before jumping to Stephanie, I would like to say a few words about her. Stephanie Breakwider is a managing director. As a managing director, Stephanie set up Mobility Goes Additive, the international leading network for industrial AM in 2016, with the aim of pushing 3D printing into series production. Now, MGA has two divisions, mobility and medical, and more than 140 members. After graduating as an economist from Technical University of Hanover, Stephanie started her career in the mobility sector and has since held various management and project management positions at the Deutsche Bahn since 2015. She has the corporate project 3D printing at the Deutsche Bahn. In addition to her work at MGA and DB, Stephanie is the initiator of the Women in AM network and actively promote women in AM industry. And that's how we also typically promote women in 3D printing. Stephanie, welcome to our stage. The floor is yours. Thank you for making time for this presentation.
Thank you so much, Malika. I'm really looking forward to this very, very special event, and yeah, I'm really happy to be with you. So what you can see already on this picture is where I'm coming from. I'm coming from the railway sector, and within the railway sector we've discovered additive manufacturing nearly 6 years ago. And I would like to tell you a bit about what we've done in the meantime. Okay. So if you take a closer look about additive manufacturing in general, many of those technologies come from Europe, many even come from Germany. And Germany and also Europe is quite strong in those branches and sectors where we have a very high level of regulation. So in the defense sector, aviation, of course, where they save a lot of weight. In the shipping industry, to create homecomers, which means spare parts to bring those ships home wherever they might be at the moment. We also talk a bit about the medical sector as well as the automotives, and of course a lot about rail. Now, talking about the automotive sector, they are really struggling at the moment with a lot of strategies they are focusing on. So additive manufacturing plays a minor role at the moment. What they do is they discover a lot of tooling aspects, but not the spare parts in a huge number of parts at the moment. So this is why I would like to come to the railway industry, where we tried 6 years ago to focus on parts which we can't get anymore at the markets. So what we are looking for are quite big parts, since the rail usually is looking for very big parts, and we also need an equivalent for forged parts. What is common to all those parts is that we need a lot of certification, since we are talking about trains where hundreds of people are traveling with. So what are the main technologies we are using in the railway sector? A lot of FDM. This is due to the fact that our high levels of quality of flame retardancy are just and only covered by FDM materials. We use powder bed fusion quite a lot, and later on I will show you some parts what it's used for. So for instance, in the polymer sector as well as in the metals. We also tried out multi-jet fusion, since there we can cover a lot of different parts, and also the coloring aspect is very interesting. And we need big metal parts, and therefore we use wire arc additive manufacturing, which you can see in the lower right. So this is a typical part we've printed for the rail sector. It also is responsible for the air conditioning system. This is a driver stand you can see here. And this is a very typical part. And what is really interesting is that it is quite common, like the aviation parts from Lufthansa or all other flying companies, but their design is just a little bit different. And therefore, we need this very high level of flame retardancy. You might ask why it is so important, and we have a lot of materials which are already certified for the aviation sector. Yes, but that may be not sufficient. Because in the aviation industry, as soon as you've landed a plane, then you have like 90 seconds until the latest the plane is emptied. In a train, you might need 12 minutes or 15 minutes coming out of a tunnel, being able to stop anywhere, getting all those people out of the train. And if you take into account that what it might mean to toxicity, and also we don't have any oxygen masks in trains, so you will understand that we have a different level of flame retardancy, and that can just be covered with FDM technology. In the railway sector, we have also very interesting cases which are very much individualized. So handrail signs for blind people is a very interesting case, because those are very individual. They say this is the street exit XYZ. So those signs are very individual, and you always need the translation into Braille scripture. And therefore, we tried out additive manufacturing of metal parts, and this even lowers the costs up to 50%. So this is really, really interesting. As I already mentioned, railway industry needs a lot of very big parts, and those big parts might also be something like this. So this is a box, a 27 kilogram heavy stainless steel box, which we have on high-speed trains going 350 kilometers per hour. And of course, that is a safety relevant part, because it prevents a train from getting too much into the curves. Therefore, we need a lot of certification. And if you do something like that, you really have to cover a lot of certification processes. So this is what we've done. We put it on a test stand and simulated another 30 years of operation, but we just need another 7 or 8. So we did a lot of testings. We did a lot of CT analysis, and now we're absolutely sure that this part is exactly as good as the former part. Because as soon as we try to exchange an obsolete spare parts, then we have to fulfill that form, fit, and function is the same as before. Yeah, and if you go to the printing industry, of course, every printing provider will tell you, I can do everything, which is nonsense. So this is why we initiated an audit in cooperation with the certification body TÜV Süd. And we asked our printing service bureaus to do this audit before they deliver parts to the railway companies. This is a general audit logic, which can also be used by other sectors as well. Yeah, so something which came up the year before, so 2021, is the tooling aspect. So usually in other sectors, you will find it the other way around. Usually they pick the low-hanging fruits with tooling, and afterwards they do spare parts. We did it the other way around, but now we also started doing spare parts. And what you can see are little fixtures and templates with can be used to fix little stickers, like here the headrests of seats. And so before they always had to measure how to fix that little sticker, and now they just have a very easily printed help to do this quite easy and fast. Fast, lean management are also big issues in the rail industry. So this is how we support lean projects in the rail industry with printing little fixtures for such shadow boards. If you might ask, what do you use additive manufacturing in general for in the railway industry? So for us, it's a great solution to get our hands on printed parts from parts we couldn't get at the markets anymore, clearing obsolescence. We also already integrated functions to make maintenance much easier. We even picked some very interesting economic cases. You don't have any minimum order quantities, and especially in the railway sector, we are often talking just about 1 to 50, 1 to 500 parts which are needed. So additive manufacturing comes in and makes sense. We print in our premises and maintenance workshops a lot of tools in the meantime, and we ensure part availability. So what are the latest trends in rail? So what we're needing is an equivalent for rubber parts. So we figured out that silicon printing would be very attractive to us. So this is a technology we are just about to test. Another thing, printing of concrete. And if you dive a bit deeper into printing of concrete, you will find out that there at the point the printing of spare parts was approximately 5 years ago. So they have a bit of way, but it's already very interesting. Yeah, what kind of rubber parts am I talking about? I'm talking about seals, bellows for dust covers, bumpers, and some elastic holders. So there's a huge variety. And they all have in common that after 6 years, no matter you use them or they are still in your warehouse, you have to throw them away. Because then our regulations say that you are not obliged to bring them into the trains anymore. So this is why it really makes sense to print those parts in small numbers on demand. And with that case, we can save millions of euros. In the meantime, at Deutsche Bahn, the German railway company, which is a huge corporate, there we have more than 300,000 employees, to give you an idea. We started 2015 with the first printed parts, which was a coat hanger. Then we founded 2 years later Mobility Goes Additive. And that was the idea, to get into an exchange with other companies about printable parts and their experiences with certain materials and so on, and to enhance the number of printable parts. 2018, we've printed the first huge metal parts. And then we established something we call an employee competition to get our hands on the great ideas of our employees. Our next big aim, and this is really a huge task, we would like to be capable of printing 10% of our parts on stock. And to give you an idea, just in the rolling stock segment, and we also have a lot of infrastructure too. In the rolling stock segment, we have parts worth 600 million euros on stock every year. As soon as we can exchange that against printed parts on demand by maybe 10%, we have a pure cash out. And this is what we are aiming for next. In the meantime, we've printed more than 25,000 parts and brought them already into the trains. And there we are talking mainly about spare parts. So in our employee competition, and that addresses not only engineers, but also all those people throughout the company, we have 5 categories. We got more than 130 ideas. We had 7 finalists and 1 champion, of course. And here you get to learn what were the ideas. So we have the category in new shine, and there we had a snap lock for folding tables. We have an optimized rim protection for wire string in the cockpit, and that broke before, and just with a very little part, we prevented that. On and along the track is the next category, talking about infrastructure use cases. And there we designed a simulation model for railway construction projects. And those are very, very expensive, talking about billions of euros. And if you can talk about who's doing what in advance using such a printed model, then the printed model is much cheaper already than the previous model. And you can save a lot of money because everyone has a different understanding due to the model. So, of course, if you want to get your hands on the great ideas, you need also to honor your idea people. And this is what we did in a huge conference. And one of our board members, Sigrid Nikutta, she's here in red dress, also a woman, by the way. She did this in a very, very nice way. And those people, and we're talking about maintenance workers, were really happy to be in such a great event. We brought together all our experiences in the network, not only from the railway companies, but beyond, in a book which is about AM change management. So if you want to introduce additive manufacturing in your company or corporate, then you always have to bear in mind it's a change management project. What's the next big topic? Sustainability. And for the sustainability aspect, we have to talk about circular economy. And there we already have a lot of very interesting answers from the 3D printing industry. Some I've mentioned before. And now we've done a calculation for the metal spare part. In this case, it's a cargo hinge. It is about that big. And there we analyzed. First, we optimized the design, and then we printed it, and we compared it to the casted, milled, and of course with the printed subject and spare part. So from the original to the AM specially designed part, we've done a lot of analysis. And what's the good news is you save a lot of weight, which is not the crucial in rail, but you also save a lot of material, which is much more interesting. And of course, you save also a lot of energy, especially compared to the milled part, and therefore also with concerning the CO2 emissions. So therefore, we have for the first time real numbers where we compare different production technologies, and now we know that additive manufacturing is the sustainable technology to choose. For instance, this is one of the working groups in our network. We have a lot more in the mobility and also medical sector. And if you should be interested, don't hesitate to contact me. Everyone is talking about becoming more independent from supply chains, also if you want to print vaccines. And this is a new production machine. It's a very huge one at the moment, but in fact, it's a 3D printer for mRNA vaccines. And yeah, so 3D printing already does a lot good in medical, as well as in the pharmaceutic sector, where you will in the future find a lot of printed pills. That is also a COVID answer. That's a 3D printed plaster, which you can dip into a vaccination liquid, and then you can just push it into your finger. It does not hurt as a needle. So maybe for some people who are still a bit skeptical about vaccinations, that might be a great solution. Yeah, so in the network, we have founded with 9 founding members. We have a lot of users of printing service bureaus, of institutes and universities, of machining producers, consultancies, software companies, as well as material providers, with at all 140 members. And if you want to take a look at our website, WeBoost.am, you will find many, many more very inspiring use cases and materials and what they are suitable for. So this will be like a 3D printing wiki in the future. And if you should be interested to bring in your cases, please contact us. And yeah, so Germany is a very interesting market to additive manufacturing. If you're looking for a place to be, to meet, for a co-working space in the special additive manufacturing setting, I would like to invite you to our industrial additive manufacturing hub located in Berlin, and very close to the center. And yeah, so since we're now in a Women in 3D Printing event, and I'm really, really happy that this great organizing team set this huge conference up, we are doing something similar, a bit smaller, which is called Women in AM. It's also a conference now being held for the 5th time this year, and where also just women enter the stage and talk about great use cases and use the pauses to get into a networking. Yeah, if you're coming from the sector which is interested in aero and space, I would like to invite you also to one of our next meetings. And yeah, if this should be so interesting to you that you would like to become a member of MGA like these brilliant and beautiful people, don't hesitate to call me. Thank you so much for your attention.
Okay. Thank you, Stephanie, for this wonderful presentation throughout application from tooling, spare part, and so on until various processes. It was really insightful. We appreciate that. And congratulations for the Women in AM. I encourage you, to get in touch with the community of women in 3D printing in Europe and in Germany. I believe you guys can host very good events together. I would like to ask a few questions that have been upvoted here in our Q&A. Stephanie, how do you select parts or spare parts to additively manufacture? And what are your guiding factors?
Yeah, so this is a very important question. So when we started with our corporate project, we tried to do this top down. So to get an analysis throughout our SAP systems, and we totally failed because usually you will not find this information in your systems, whether a part is printable or not. Sometimes we don't even know about the material because we are not a producing company, we are just a maintainer. And therefore, we put it upside down and said, then we have to create a bottom-up process. So we went to our maintenance workshops and asked our colleagues, so they indicated what are the critical parts. And then we looked for specific solutions. And this is how we do it very successfully. But this year, we again want to do the top-down process and focus on that again. But it's not really easy. Therefore, you need a very broad knowledge and experience about the printable materials and also the suitable technologies, which we, in the meantime, build up. And but usually you have to talk to people and you cannot do enough communication. This is our experience. So we did a lot of communication throughout the company. But when we put in the external press, then once in a sudden, many people woke up. And this is also a very interesting experience we had.
Okay, that's wonderful. We still have time for questions. Stephanie, do you have in-house AM capabilities or you outsource? If so, can you mention few partners?
Until the last year, we 200% outsourced everything. So some of the partners are, for instance, Blue Production and Protique and Fit and some others. And Siemens, of course. So our former suppliers in the rail industry also started already, at least the huge corporates, with additive manufacturing, and Siemens is really a great and big player. And so in the meantime, which means last year, we set up the first machines within the corporate. So we already knew that we want to have a big machine, like for instance, a big wrap. We set up in one maintenance site in the south of Germany. In the north of Germany, we established polymer machines to print spare parts and not just tooling, which we do on the big wrap. We try to establish printing centers in different parts of the country, but with a very specific focus, because we learned that you need very intrinsic, motivated people, and you need a lot of knowledge to cope with the machines, the materials, the designs, and anything else.
Great. Stephanie, I saw in your presentation you mentioned one of the largest parts. What process you use there and who is your partner?
Yeah, so for the metal parts, we use wire arc additive manufacturing, and our partner there is machine-wise Gefertec. And printing-wise, it's Rolf Lenk, also a printing service bureau. Coming to the polymer sector, where we use big parts, it's on the one hand Siemens, on the other hand, machine I've already mentioned, and printing service bureaus for the parts was, for instance, also, I guess, Fit.
Wonderful. We had very busy Q&A here. So we have a question that says, through your role, how are you helping other companies learning from Deutsche Bahn experience to expand AM application? If so, any relationships in Africa?
Yes, we have already some relationships in Africa, but I would love to grow that, because I think that Africa is really, first of all, it's a huge market. Then there's a lot of need, and I think this would be a great cooperation. So I'm very, very open to that. What we do within the network is that we share a lot of experiences. And now we've really a lot of members, and just a couple of weeks ago, one member addressed us and said, could you please find out what's going on in the copper printing field? And then we shouted it into the network, and just within a couple of days, we had a pitch event of 18 companies pitching materials, technologies, use cases, and so we got an overall overview. And this is typical for the network. We also try to solve standardization subjects together. We do in the network anything one company cannot solve on its own, like, for instance, also education, ecological sustainability. Talking about a lot about materials. So there we have a very successful materials working group, also led by a woman, Tina Schlingmann. She's also in the conference. And yeah, so this is what we're trying to solve there.
Okay, that's great. We are done with our question, but I would like to share with you some of the comments from our fire chat here. We have Martina Gildia say, absolutely brilliant presentation. Thank you. Matt Griffith said, thank you so much for sharing today. And also, we have Mufaro thanking you for the enlightening presentation. And Matt Griffin says, so inspiring, all of your work and contribution to moving industry and culture forward, Stephanie. So, and you mentioned, you know, about sharing. Sharing is caring, and in this case, caring for AM to grow further. Thank you, Stephanie, again, for being a great presenter and sharing this wonderful presenter. We really enjoyed it, and you can see through the question and the chat. Thank you again. We appreciate your presence at the Taipei and the industry tech. Wonderful. Please feel free to chat with the participant and network as well with them further.
Thank you so much. And ladies, let's boost AM. Thank you. Bye.
Okay, great. Thank you. You can just put your camera off and stop sharing your screen and your mic on. Stephanie, please. Okay, great. We are right on time. Okay. Okay, we are right on time, dear participants at the industry track. Now we can jump, and I'm so excited to introduce a great panel moderated by Ingrid Pristine from Cyprus on industrial production with AM standard and certification. Joining Ingrid is Victoria May from Protal UK and Lucia Cavallo from Bureau Vita. I would like to bring them to the stage with us here. Welcome, Lucia. You can put your camera. Yes, great. Upcoming is Victoria. You can put your mic and camera on. And last but not least is Ingrid. Ingrid, welcome, ladies. Let's just wait for Ingrid to jump with us. Okay, welcome, ladies, and thank you for giving us your time today and working hard for this panel and share it with our viewers today. I would like to give the floor to Ingrid Pristine, our moderator for industrial production with AM, discussing standard and certification. Thank you.
Thank you. Thank you. Thank you, Malaika. Thank you for the introduction. Thanks to everyone to be here and share our experience. Thanks, Victoria and Lucia, to be here, and we can start. I will just share my screen first. Just a second. You see my screen? No, are you able to see the big presentation? Yep. Yes, but I'm not able to show you. 2 seconds. Oh, okay, just a second. Okay, now fine. Do you see the presentation? Yes.
Sorry, Ingrid, can you put it in diapo mode?
I don't, it's not. Are you seeing that? No. Oh, I'm sorry about that.
If you can send, yeah, just put it on presentation mode. Maybe go at the top and say present mode.
I did present mode, but it's not accepting. Oh, I'm sorry about this.
Okay, but like this one is, it just, we can see the writing.
Yes, I know.
I think
Because
you just need to share the right part of your screen when you go on present mode. It's showing your desktop rather than the presentation in presentation mode.
I know, and if I go this, you cannot see it, no? When I see this presentation myself. Oh.
Okay. If you can send it quickly to me, then I can share it from your side, my side.
Yes, I have sent it to you already.
Okay, I will share it from my side.
You should have it.
Is it on email?
Yes, it is on email, yes.
Okay, yes, I see it now.
Okay, great. Sorry about that.
No, don't worry. Okay, I'm just gonna quickly download it. Oh, no, I can actually share it here. Let me just share screen and then you can tell me how it looks like. Share. Okay. Can you see it on my screen?
It's charging
Yes.
now. Yes.
Is it perfect?
Yes.
Just tell me when you need next slide and then I will press next slide for you.
It's better. Thanks, Lucia. Thanks to everyone to be here, and thanks for Malaika to introduce ourselves. As you see, I will introduce myself. I'm in this market over 25 years. I'm mostly experienced. What I have is in the SLS printing sector with polymers. I got my first education at EOS, and after a while, we saw that it's a very interesting market, and I found with my husband Cyprus 2004 with the idea to be a service provider with polymers. A very soon time, we found out that there is more than prototypes. Already 2006, we present the first finished parts, final part with surface preparation, with color. But on that stage, everyone was saying, now this SLS production will be just only for prototypes. But in the meanwhile, this topic changed a lot. And we are producing now end parts. The most interesting part in our company is the production of eyewear. We have many sectors, but the biggest sector that we have in the production is 3D printed eyewear in large quantities. We print mostly 60,000 frames per year. And on top, we do service providing for already printed parts. And in this sector, we are doing finishing over 120,000 pieces per year. So it's quite large amount. And this market is getting bigger and bigger. Yes, this is my part. I will go to the next one, to Victoria, please. Victoria, feel free, introduce yourself. And yes, hello, Victoria.
Hi everyone. Yeah, my name is Victoria May. I am a sales and marketing manager at ProTotal UK, formerly 3T. I've worked in the industry for around 10 years. I actually started off being a CAD engineer and working with the EOS machines back when Prototyl was 3T about 10 years ago. And yeah, I've worked in various roles in that last 10 years and ended up on the sales and marketing side. And at Prototyl, very similar experiences to Ingrid at Cyprus. We're a polymer AM manufacturer, and we work across multiple different industries, from medical to aerospace to motorsport.
Thank you, Lucia. Vittoria, now Lucia, it's your turn. Sorry.
Hello everyone. My name is Lucia Cavallo. I'm in charge of the industrial product certification at Bureau Veritas at global level. Since the beginning of my career, I have been involved in the standardization or certification process. Before as a representative for the mechanical manufacturer industry, and then I reached the Bureau Veritas already more than 10 years ago. Why I'm here today at Bureau Veritas, of course, we are required more and more to certify 3D printed components. And also, as we strongly believe that there is a scope for assessing technology and personnel and to verify and certify product. So this is the reason why we decide to develop a voluntary certification scheme to certify, so not only product, but also materials, processes, and personnel in case of using additive manufacturing. We also published a white paper explaining our methodology that is available for free on our website. We think that this will facilitate a wider adoption and a greater business value from additive manufacturing.
Great, Lucia. That's a nice point. We can go third. Could you turn the next slide, please? Then we can keep going on that. Yes. As you see, there's a lot of standards and certifications on the market that we have to fulfill. And I could jump to my question to you both. Maybe first to Lucia, could you name some standards and certifications, because you are really involved in the last years in this topic, so I think you are the right person for that.
So each product needs to satisfy, when we intend to put a product on the market, of course, we need to satisfy the regulation of the market. If we speak about my sector, that is the industrial product certification, for instance, I can nominate the machinery directive for Europe, the low voltage electromechanical compatibility that are, for instance, the regulation that are applicable to AM machinery. And then speaking about the product, we can nominate the pressure equipment, the construction product, the interoperability for RAY, medical device, ATEX for equipment to be put in a potential explosive atmosphere. And then we have the same type of regulation covering the same product outside Europe. Of course, I can mention the GB standard for China. We work a lot on ASME, that is the regulation covering the pressure equipment in United States, or the S-Mark, that is a product certification from Australia. Of course, all these regulations and standards have been written considering classic manufacturing method. Therefore, it will be necessary to update regulation and write a new standard. One thing that we would like to highlight that we have already what we call a legislation framework. As for instance, I can make the example during what happened during the sanitary crisis. The European Commission published a document that was on the conformity assessment procedure for 3D printing and 3D printed product to be used in the medical context due to COVID-19. And this document clarifies that the legislative framework exists. For instance, machines are covered by machinery directive, and products are covered in this case by medical devices regulation. But in absence of dedicated standard, other standard may be used. In fact, one important thing of the new approach framework that we have in Europe is that all the regulations are written as a series of essential safety, health and safety requirements, and therefore the manufacturer is free to use whatever specification you need. So when manufacturer cannot really on harmonized standard, as they do not exist yet, he can demonstrate by other means, for instance, experimental method or other technical specification, how the essential health and safety requirement could be satisfied.
Yes, thanks, Lucia. And how is your experience, Victoria, as a service provider? What standards you have to fulfill?
So as a service provider, our main sort of standards or certifications that we work to, we have mainly with ISO standards. So obviously our general manufacturing is under 9001. And we also have ISO 13485 and EN 9100. So we were actually the first bureau, I think it was maybe 10 or so years ago now, to have all three of those standards as an additive manufacturer. So that's our main experiences there, and they're obviously more based on the processing and how you actually manage your systems to be able to make parts for medical for ISO 13485 and aerospace parts for EN 9100. We also find that as a service provider, as there are so many standards and certifications either existing or being created, we tend to have customers come to us with quite specific needs. And we have in the past worked with our customers to actually create their own kind of internal specifications that they can work with. Because a lot of the time they're quite new to additive manufacturing, whereas, we have 20 years experience in that. So in the past, we have created specifications so that we can say to them, depending on the use case for the parts, we could be looking at how they should maybe qualify materials or how they should qualify parts, or whether they need to be machine specific standards and things like that.
And adding to this, within additive manufacturing, how you define production versus prototype, how you see that as service provider?
So for us as a service provider, it's relatively clear for us. So a production component, how we define that, is just a component that actually has an end use. So it's going to be going into some real world cases versus a prototype, obviously, the name suggests, is a prototype component that's not necessarily going to be used repeatedly. What that means, though, is that obviously production, usually people think that must mean, lots and lots of volumes, but actually it doesn't have to. So in terms of the sort of standards that might be applied for certain things, for example, in medical applications, we make production components that are used in surgical situations, and we produce them under 13485. But they may be, one-off products, because the whole kind of beauty of using additive manufacturing within the medical industry is obviously that it can be completely custom. So we may actually find we may make 20 components, but every single one of them is different, but we still class that as a production process that we need to, add a few more things than we might do for a standard prototype component.
Okay, and Lucia, what do you think about these low quantities? Do they justify the needs and costs for the qualification needed?
So, if we speak from our point of view as inspection board, of course, if the product is subject to what we call mandatory certification, then if it is a single unit or it is a huge series, there is anyway no choice, it has to be certified. But what we can say that the standard and regulation normally have been written also with the support of industry. It was my previous job, for instance. And normally the aspect of cost of certification are taken in consideration into regulation in the standard. One important information is that European Commission estimated the cost of certification, and it has been calculated as 0.5% of the final value of the product, including the internal cost of quality. So if we take the European directive, depending of or also other regulation, normally depending on risk category of the equipment, and also the fact that the equipment is manufactured only one single product or in series, there are different procedure of conformity assessment. So normally this has been taken in consideration. Of course, so this is for mandatory certification. If we speak about voluntary certification, then of course it's not so evident, and the value of the final product or the size of the production are really relevant to decide if go or non go versus a voluntary certification. Also, if sometimes voluntary certification can be imposed by the market, so also if it is not imposed by the regulation, so imposed by the client, for instance, or I would like also to highlight the added value of a certification for a product in the market.
Yeah, I think it's my experience is if we start a certification at the beginning, it's a lot of time and cost, but after you have done once, then for the next projects you are prepared, and so these costs are not loose, you know, so you can, the next production will be already involved with a qualification. So can we jump to the next slide, Lucia, because I will present a sample of production, a really success story of production. In this case, our mostly experience, what we have with production is 3D printed eyewear. Last year, the company Baba, eyewear producer from Portugal, brought to the market a collection for the Japanese architect Kengo Kuma, with a collection for the Olympic Games together with Mamona. She's an Olympic winner, and the idea of this product, Kengo Kuma, came to us asking for sustainable production with material that are renewable materials, and everything printed, because his ideas are not cannot be produced in other way. And they took the material PA11, material produced from castor oil, and for him was very important that at the beginning already starting producing or planting the beans has to be certified, that there is no competition in the production with water, or that the people or the farmers get well down paid. And this should be really sustainable from the beginning to the end. So it means that when the customer doesn't want to have the eyewear anymore, that this eyewear has to be recycled, go back to a recycling process. And the nice is that this PA11, the company who produced the PA11, we came together and say, okay, we will be able to bring back the printed eyewear after the customer doesn't want to have anywhere and be really recycled. So we could convince him with this material that it's a strong material. PA11, it's really nice for, as you see in the slide, the structures are some places are the very brittle, but with PA11 we have a strong material with a strong UV stability. The colors are UV stable, and the post-processing, it was kind of difficult to do the tumbling of the PA11 because it's a strong material. But at the end of the day, we have a really nice product, and this is a sample that everything has to be covered. For example, for this was very important to have for each material that we're using for the production, the colors, the infiltration, everything has to have a Rich and Ross certificate, and every footprint has to be listed and fulfill all these expectives. So with this, I would really jump to the next question, maybe to Victoria. What are the key difference between components and approval of material process? So the approval from of the components versus the approval of manufacturing process, because I was talking about the approval of the each components, but how about the manufacturing process too versus?
So in our experience, the approval of the manufacturing process is obviously very different to looking at part level approvals. So from a manufacturing point of view, again, it can be very different depending on industry. So some industries don't put too much emphasis on the machine you're using or necessarily how you're doing what you do with that, whereas other industries are really specific. So for instance, within the aerospace industry, we have instances where for them to qualify a part, they first obviously have to qualify how they're going to make it, and that can go down to a really granular level to where they actually approve making those parts on a very specific machine, and they can't move away from that once that approval's been done. So that's where it can sometimes incur costs in the future, because potentially, for instance, with an EOS machine, you may have qualified parts on a P760 and your service provider may stop having that machine and move on to a 770. All that qualification then needs to be done again in certain industries like aerospace. So, you know, even down to the material type and the age of that machine can be quite important, and they can't kind of digress from that, because obviously for aerospace parts, they're pretty safety critical. If you get something wrong, you've potentially got lives on the line. In terms of the standards we work to, obviously the ISO standards, as I mentioned earlier, are really more specific to our sort of management systems and how we process our parts. So we have to create, for instance, for ISO 13485 for medical, we have a methodology of how we process an order for a medical requirement. So from quote all the way to when it leaves the building, we have a very specific process for that, and our customers will come in usually and verify that. So having the standard itself is obviously a great start, and shows people that we can manufacture parts to that standard. But obviously many medical providers are going to want to come and actually do their own audits as well. So they have their own things that they want to check that manufacturers are actually doing before they will be able to commit to you making parts for them. So our medical process, we have a completely different powder stream. So we don't mix our powders for medical work versus any of the other work that we do. We limit the recycles on that as well. So within polymer laser sintering powder-based materials, we recycle that a lot, but within the medical stream, we cut that down so that we can really have a really tight control on our materials as per our customer requirements. So the way we process those materials, that's not dictated by 13485, but that's customer requirements that we have to do. So there's a balance between the standards and also what the customers actually want for us to be able to manufacture parts. Then when it comes down to actual component approval, it can again vary quite a lot. So again, within aerospace, you tend to find that they're going to want to know a lot more about the mechanical properties of that material. So we'll have orders where we make the same parts repeatedly for years, but we always have to build various test bars with those parts. And when the parts come out of the build, we have to, do tensile tests, etc., on those parts, so on the bars, to verify that the parts can then carry on being processed. So there's quite a lot of differences, and then obviously, standard sort of inspections that need to be done to make sure that parts comply with drawings, and then also verifying certain ways of how we post-process the parts. So it might be in terms of colouring. We've got
different colouring for automotive parts than we do for non-automotive parts based on the properties of that die and how it performs within a kind of car environment. So those are the kind of key differences between manufacturing process and parts. They're quite kind of different things to look at.
Thanks. Very, very interesting. It's exactly the same experience we have. I will jump to the next question, Lucia, to you. Maybe you want to put your slide. Exactly. Thank you. So my question, how can we satisfy the industrial product regulations in case of additive manufacturing production?
Yes, of course. So as defined before, the first step to be followed when we decide to design a new product is and to be put a product that should be put in a certain market is to identify what is the regulation that is applicable. Once the regulation has been identified, it is necessary to study the requirements and the conformity assessment procedures and to organize from the design to production and control checks to be done, all in order to satisfy what are the technical requirements. If they are not supporting standard, I'm calling supporting as they are not of harmonized standard. Now in the UK, we have what they call design standard or other standards supporting regulation outside Europe. We can use other standard. For instance, I can mention the ISO ISTM 52901 that contain a general principle for additive manufacturing. So then some of the existing standard related to manufacturing and use of a specific product are applicable whatever the type of machine or process used, so it can be used. It is important to choose the correct raw material, of course, and this is the importance to have also raw material certified. It is important to apply appropriate post processes that should be also validated. But finally, if we need some other additional specification, we can use it, or experimental methods can be used with the assistance, for instance, of a third party, or also in case we can also contact a national competent authority to verify if what we are proposing can be acceptable. I can list a main step to obtain what we call a type certification. That is, of course, the identification applicable regulation, what we call design review, that is the FEM validation, the basic material characterization, and if the raw material has been already certified, we can perform some tests on the specimens, product process assessment, including post-process operation, and as final, the product validation test on what it is, the final product. And then finally, a type approval certificate can be issued if a certification body has been involved in the process. Can I ask to Malika to go to my slide, so slide 4? Yes. So this is a case study that I would like to present that is very significant as it is a certification or lifting accessory that is a product that is covered actually by the machinery directive. And this is made so in fiber filler polymer, so nylon mixed with the chopped carbon fiber instead of of course the original component that has been made by steel. The AM technology used was the fusion deposition modeling. Here we follow the step. So identification, applicable regulation, machinery directive, design review, FEM model validation has been done. Basic material characterization, and in particular have been done tests on specimen using ISO standards that normally are applicable to steel, but of course our experts have validated the part of the standard that could be used. So in particular, traction strength in accordance with the ISO of 527 part 4, compression strength in accordance with ISO 604, 3-point bending strength in accordance with ISO 178. Then production process assessment, of course, and product validation step on the product. In this case, according to machinery directive, it is necessary to carry out load cycle phases. Therefore, finally, our component has been, as a lifting accessory, has been certified according to machinery directive, with the big advantages that the weight is now 2 kilo instead of 10 kilo before. The working load has been multiplied by 5. And of course, as for all product with additive manufacturer, it is cheaper and faster and can be printed only when needed on site.
Thanks, Lucia. It's a really nice sample to see why additive manufacturing can move a lot in the production. And Victoria, you as a service provider, getting in touch with these different kind of regulations, how can certification bodies work better with service providers to ensure standards are in line with industry norms and abilities? How you see that?
So yeah, as a service provider, it's quite tricky. So sometimes you can find out about a kind of AM specific standard to a certain industry just when someone from that industry is actually asking you for some parts, and they just happen to say, can this, ASTM this or whatever the standard might be. So that can be quite sort of limiting in terms of there's so many, and I think one of the questions that have popped up is this probably will help to answer that. There are so many bodies, there are so many standards, and there's so many people looking at additive manufacturing standards. It can be a little bit of a minefield, and also quite difficult sometimes to actually interpret the standards themselves. Obviously, they're written in very specific ways that the people who write the standards makes perfect sense, but the people who have to interpret them to be able to put it against their manufacturing processes, it can be quite tricky. So some of the things I think generally is they just need to start working together more and much more openly. I think that's a real key thing. So sometimes you'll find that certain standards might get written. So previous experience on metal additive manufacturing, where it can be a bit more stringent in terms of material qualification. We were working with an oil and gas project, and the customer came out with these certifications and standards that have literally just been written for additive manufacturing. And it was all about material qualification, but it was so heavy on upfront qualification of that material that it ended up pricing out probably nearly every project that would have ever started, because there was so much testing at the beginning. And sometimes standards are obviously written with certain companies. There was a heat treatment company, for instance, involved in this particular one. And so lo and behold, the standard said that everything needed to be hipped after it had been printed, which is certainly not the case with DMLS printing. So I think there's a lot that needs to happen there, where standards tend to be written with whatever things used to be done in mind, and that we can't look at things like that, because that's not how we work in additive manufacturing. It's very different and it's very new, and you can't compare, qualifying billet material to qualifying powders. It's not the same. So I think certainly being more open and working more closely together with sort of research facilities and people that are creating the standards like ASTM and things like that would be a real big help. As well as that, we've had here in the past, when we have to work to say an ISO standard, we have had the bodies come in for training. So they've actually come to us and given us, a day or two's training on the whole standard, because as I said, they can be quite hard to interpret if, you know, that's not your daily job. Obviously, we have a quality team here who that is their daily job. But even then, there's a lot to take on sometimes, and having training days where people, you know, the people that have written them can actually go through things and you can properly understand how to interpret what you need to do to make it fit with your process is certainly very important. We did a very small project that involves ASTM. We're looking at whether there should be some standard to how much you can recycle nylon powders. Everyone does that differently now. I'm sure Ingrid's company does it very different to how ProTotal do it, and everywhere else. And I think, again, that's got some value to it in putting some kind of standard on that sort of thing. But it also, you have to be very careful, because it could end up causing huge cost increases for certain companies, or it could, you know, determine quality either in a positive way or in a negative way, depending on what that standard is and who that standard's written with. So yeah, I think there's lots of ways that they just need to communicate much more and work together, so that the bureaus like ourselves can actually understand them and know, you know, which ones are relevant. Because sometimes you have standards that are written for the same things but by different people. Which one's the right one? You know, there's not that kind of one mainstream standard at the moment for AM.
Yeah, and that's why I asked Lucia, for example, are the standards, if they are fast enough, if you want to involve the standards in the production on the product, are these standards fast enough or not?
But actually, there are a lot of standardization working groups that are working hard to cover the lack of standard in the additive manufacturing. For instance, our experts are engaged in many different working groups, starting from ISO TC 261 additive manufacturing, all the joint working group related. I would like also to mention the CEN-TC 54 working group 11, that is quite difficult job, as they are working in the pressure equipment and components that are fabricated with additive manufacturing method that are really completely different of what we know with pressure equipment and welding and so on. But the question to the answer, they are fast enough? I think is no. I think is normally is no. As a standardization process, we know that are quite complicated. There are always so many different interests. Sometimes they are in conflict. Also, if in the last year a lot of progress has been done in improvement and simplification of standardization process, I think that the AM technologies are going so fast that standardization cannot be in line with this progress. This is the reason why we need to find other specification, use the help of technical assistance and so on.
Thanks for all you answering all these very interesting questions. I saw that in the QM question box we have some questions from Carol, and I don't know, maybe you take a look and we decide which one to answer, because we're still having time on that. I have with the highest interest, do you certify 3D printed parts or assembly for food-related materials? How is your experience? Do you have this? We have many times this question. How it's in your situation, Lucia, with the certification?
Honestly, I'm not aware yet, but I needed to come back to my colleagues, as we are really a big group. So I'm based at the head office. We have a center of excellence that is based in Italy, but then we have qualified personnel, so they could work in Germany, Spain, United States, and China. So I need to verify. For my information, I don't think it is the case yet.
Yeah. Well,
we hope that it will come, of course.
Yes. It is important. You know, I think the printing materials, they are certified. Mm-hmm. But the main problem is the post-processing, like if you're putting coatings or colors, for example, we are the color experts, and all the colors that we use are for wearables, but they are not certified for food purposes. We are sure that there are some colors that we can use for it, but we have to certify the part on that, and it makes very expensive situation because each color has their own property, and so you have to certify color by color, and then part by part, and depending how the color goes into the part, and etc. So there are many things, and there are some certain high expenses for that. But I think it is possible, but it's not ready yet. And how is your experience in that direction, Victoria?
So we work with a few companies that are in the food industry. Generally, as you said, Ingrid, like the material itself is technically a food grade material. So we work with a majority of the time with PA12, which is a food grade material. But again, it comes down to what we said earlier, that there's a difference between part qualification, process qualification, material qualification. So the material ticks the box, but is the way we process it suitable for a food part? Not necessarily. Or certainly we don't do that as standard. So in our experience, we basically tell our customers like the material, yes, that ticks that box. How we process it currently doesn't. And then it's up to them to decide if they would like to go down that route. And generally it's for prototyping, so it's not too much of a problem. Obviously the material itself sometimes is too porous to actually be used in food itself, but we do a lot of parts for food production lines. So it doesn't touch the food, but it's used on the lines, and then it's up to our customers to qualify that. And obviously anything they need from us, we can help them with. But yeah, there's that issue again with which part of the process is actually qualified to be able to do something.
Well, my experience, for example, for medical devices that are being used during surgeries, and they are colored and they are coated or they are just chemical smooth, we know they do the certifications by their own because they are responsible for that, and they do pass. So we know that the things that we're using for that are materials that really are able to use on those places, and they can be certified. But as a service provider, it's for us very difficult because we're getting all the needs, and we cannot fulfill everything. So as a service provider, you cannot pay the cost for that. So that's why I think that we need certain regulations on the market that has, that we can come together and try to make regulations on that, and different colors and materials and coatings, that everyone can use that. Not every service provider to get to that point. I think we need some kind of different place of that. We have some more questions on the panel. I don't know, Lucia or Victoria, do you see the questions? Is any of them that you would like to answer?
So there's one that Carol's asked about aerospace parts. So yeah, so for aerospace, as I said, we tend to, the qualification generally from our customers is dictated that tensile bars and things like that have to be printed with the parts in order for them to then be tested and then processed through. So your question on how would you set up the same process for spare parts? Again, it comes down to customer requirements, but if that's a requirement, then it would have to essentially force the price of spare parts up, because you'd have to incorporate the fact that you have to do that material test each time. But the caveat to that is we have other customers within the same markets even that don't require necessarily to have tensile bars made every time. It might be every few batches, and providing you're doing the production parts, which we are for most of those customers anyway, we build that data and can show our kind of consistency with mechanical properties and things like that, enough that then when there's a spare part coming into the system, you wouldn't need to do the same qualification again. But it's very much down to what customers are after, and we just work with people to make sure that whatever qualification is needed for material or process, we kind of work together to get it right, and try as much as possible, obviously, to keep the cost down, because one thing that standards and qualification and certifications do is tend to make things more expensive.
Okay. Wonderful. Thank you, ladies. Thank you, Ingrid, Lucia, Victoria, for this interactive session and attending to all the questions. Our time is up for this panel. I would like to thank you for all the preparation and your time and sharing insights. I would like as well to encourage our participants to reach out to you via LinkedIn, if they have any other question, and as well join you at the networking session now and discuss further any topic or any related things to the panel discussion that happened just now. Thank you again. I appreciate it.
Thank you all. And as
Thank
Malaika said, please visit us at LinkedIn and make your questions on there. Thank you.
Great, thank you.
You're welcome. Bye-bye.
Okay. Dear participants, please return to the main stage for the networking session. It is happening now. Just make sure you are on a floor where there is attendees. Please feel free to put your mic on and camera on. If you don't want to put your camera on, at least put your mic on so it brings you to the table and it shows you your neighbor virtual to discuss with them. And then we will see you later at the industry track again for the upcoming presentation, AM from niche to mass production at 12:30 GMT time.